Magandang araw sa ating lahat. Sa videong ito ay tatalakayin natin ang first law of thermodynamics for control mass. Kapag sinabi nating control mass, ito ay yung mga system na walang dumadaloy na mass papasok at papalabas ng boundaries. Only the energies are being transferred and not the substances themselves. Sa simula ay pag-uusapan natin ang iba't ibang uri ng energy na nalaman ninyo nung kayo ay nasa earlier years of college or perhaps in high school, tulad na lang ng kinetic energy at gravitational potential energy. Bukod dito ay dadagdagan natin ito ng ilan pang mga konsepto tulad na lang ng internal energy. Pag-uusapan din natin ang ibig sabihin ng heat, ng work sa konteksto ng thermodynamics. Panghuli ay ide-derive at ia-apply natin ang energy equation for control mass at uunawain natin kung saan galing ang iba't ibang terms na bumubuo rito. Una sa lahat, linawin natin ang definition ng control mass or closed system. A closed system, which is also known as control mass, is a system that allows flow of energy but not flow of mass through its boundary. Ibig sabihin, kung ito ang ating boundary, only energies such as heat and work can transfer from the inside to the outside and vice versa. Hindi pwedeng magkaroon ng leakages ng substances from the inside out o kaya from the exterior to the interior of our control mass. Isa sa mga halimbawa ng control mass ay yung sinaing natin before kumulo ang tubig sa loob ng ating kaldero. So, sa loob ng ating kaldero, meron tayong tubig, merong bigas, at nakatakip ito ng mabuti. Nagsusupply tayo ng heat using our stove, pero pinapanatili nating nasa loob ang bigas at ang tubig bago ito kumulo. Of course, ibang usapan pa rito kapag kumukulo na ang ating tubig sa loob at tinanggal natin ang takip ng ating kaldero. So, at this point, hindi na siya closed system, hindi na siya control mass. Let's move forward to gravitational potential energy. The gravitational potential energy is the energy associated with the elevation of the system relative to an origin or datum such as the surface of the Earth. Tandaan natin na ang mansanas na nasa puno ay subjected to gravitational attraction towards the Earth. Now, the magnitude of the energy by which the Earth pulls it down relative to the ground is called the gravitational potential energy. It is given by the formula mass times the acceleration due to gravity times the height. Sabihin nating meron tayong system na nag-travel from point 1 to point 2, as you can see in this diagram. Ang change in the gravitational potential energy as the object moves from point 1 to point 2 ay makukuha gamit ang formula delta PE is equal to mass times the acceleration due to gravity times the change in elevation Z2 minus Z1. Next, we have kinetic energy. Halimbawa, meron tayong mansanas sa ating puno. Kapag naputol ang sanga, of course, mahuhulog ito. As it falls, the amount of energy associated with the velocity relative to an inertial reference frame, just like the Earth, is called the kinetic energy. Ang kinetic energy ay makukuha gamit ang formula na 1/2 times mass times the velocity squared. Let's say we have a system that initially has a velocity of v1 and changes its velocity to v2 as it undergoes any process. The change in kinetic energy of the same object is therefore given by the formula 1/2 times mass multiplied by the quantity of the final velocity squared minus the initial velocity squared. Lastly, we have internal energy. The internal energy is the energy associated with the makeup of the system, including its chemical properties. Alam natin na essentially lahat ng substances ay made up of atoms and molecules. And ang mga molecules na ito ay gumagalaw. They could be translating, rotating, vibrating, or any combination of these motions. The energy being possessed by these substances because of these molecular motions are part of what we call the internal energy capital U. Take note na ang internal energy at ang dalawa pang types of energies na binanggit natin kanina ay mga extensive properties dahil nakadepende ito sa quantity ng ating system. Now, if we divide the internal energy capital U by the mass of the system, we have an intensive property called the specific internal energy. So it is denoted by small letter u and it has a unit of kilojoules per kilogram. Ang specific internal energy ay makukuha natin as function of temperature sa ating thermodynamic tables. So, sabihin natin na meron tayong system na initially ay nasa state 1 at a certain temperature T1 and it undergoes a particular process such that nagbago yung kanyang temperature. So, mula sa state 1, naging state 2 na siya at merong final temperature na T2. Now, there is a change in internal energy of this system, and the formula for the change of internal energy is given by the mass m multiplied by the quantity of U2 minus U1, whereas the U2 is the final specific internal energy and U1 is the initial specific internal energy. Sabihin natin na meron tayong closed system na sa simula ay nasa state 1, and it undergoes a certain process such that the final state of the system is state 2. The change in total energy is equal to the sum of the change in the gravitational potential energy, the change in kinetic energy, and the change in internal energy. Therefore, delta E total is given by this formula. Sa ating equation, meron tayong dalawang sides. Ang right-hand side na expressed in terms of properties tulad na lang ng specific internal energy, at ang left-hand side na pwede nating i-express in terms of energy fluxes that are flowing through the system. Now, what are these energy fluxes? Para sa isang control mass or closed system, these energy fluxes are in the form of heat transfer Q and work W. Heat transfer is a form of energy transfer when there is a difference in temperature between two objects. Ibig sabihin, para magkaroon ng heat transfer, dapat magkaiba ang temperature ng dalawang bagay. Ang direksyon ng heat transfer ay mula sa object na may mas mataas na temperature, so sa madaling salita, mas mainit, papunta sa object na may mas mababang temperature or in other words, doon sa mas malamig. Halimbawa, meron tayong kalderon nakapatong sa ating induction cooker. Kapag nakabukas ang induction cooker, di hamak na mas mataas ang temperature nito kumpara sa kaldero. So, masasabi natin ang heat transfer ay mula sa induction cooker papunta sa kaldero. Kung meron naman tayong malamig na tubig na nakapatong sa lamesa sa isang mainit na tanghali, so, dahil mas mainit ang ating environment, ang heat transfer ay mula sa ating environment papunta sa ating system, which in this case is the glass of cold water. By convention, heat Q is positive if heat is flowing into the system. So, sa madaling salita, if heat is absorbed by the system, Q is positive. Meanwhile, heat is negative if it is flowing out of the system, or in other words, if heat is released by the system. Next, we have work. Sa konteksto ng thermodynamics, lahat ng energy transfer na hindi dependent sa temperature ay tinatawag nating work. Maraming klase ng work. Maaaring mechanical work na kadalasan ay nakadepende sa change in volume, o kaya electrical work na mula sa battery papunta sa ating mga laptop or cellphone. Ang sign convention ng work ay baliktad sa sign convention natin ng heat. So that is, work is positive if it is done by the system, and it is negative if it is done on the system. Now, let's take a closer look at mechanical work. More specifically, in a situation wherein there is a gas confined in a piston cylinder assembly. Sabihin natin na ang fluid pressure sa loob ng cylinder ay P, at may contact area ito na A. The normal force, F, can then be expressed as F equals P times A. Now, if we recall your mechanics class, alam natin na ang work ay defined as the integral of the force with respect to the displacement. That is, W is equal to the integral of F dx. Substituting force, we will then have W equals the integral of P times A dx. Now, let us recognize that if we multiply the cross-sectional area A with the differential displacement dx, we will get the differential volume dV. Therefore, our final integral will be W equals the integral of P dV. Now, what does this integral mean? Ibig sabihin, ang mechanical work ay equal lang sa area ng pressure versus volume diagram. So, this applies only under the assumption na ang process natin ay ideal. So, what is the first law of thermodynamics? Ang first law of thermodynamics ay restatement lang ng conservation of energy sa konteksto ng thermodynamic processes. Conservation of energy says that energy is neither created nor destroyed. It is only converted to other forms. Sa madaling salita, ang energy ng system na binubuo ng gravitational potential energy, kinetic energy, at internal energy in the case of a control mass system ay maaaring i-convert to streams of energy in the form of heat and work. But nevertheless, it is not destroyed. Let's say we have this system initially at state 1. Matapos nitong mag-undergo ng isang process, the system will now be at state 2. For this system undergoing a process 1 to 2, the change in energy inside the system will be converted to energy fluxes through heat transfer or work. That is, the change in energy within the system equals the net heat released during the process minus the work done by the system during the process. Mathematically speaking, we have delta E is equal to Q minus W. Take note na yung Q and W na nandito ay nagko-conform doon sa sign convention na pinag-usapan natin kanina. Ngayon, kung papalitan natin ang delta E ng equation na nakuha natin mula kanina, ang final form ng ating energy equation ay ang sumusunod. This is now the first law equation for control mass. So let's proceed by solving a sample problem about the first law of thermodynamics. Let me just read the problem for you. An object whose mass is 140 kilograms experiences changes in its kinetic and potential energies owing to the action of the resultant force R. The work done on the object by the resultant force is 150 kilojoules. There are no other interactions between the object and its surroundings. If the object's elevation increases by 30 meters and its final velocity is 60 meters per second, what is its initial velocity in meters per second? Let g be equal to 9.81 meters per second squared. Round off your answer to the nearest hundredths. So, makikita ninyo dito sa ating screen ang ating first law equation, or basically the energy balance for control mass. And here on the right, you can see a schematic diagram. Down here is your object in state 1, and up here is your object in state 2. According to the problem, work is done on the object. Therefore, we can say that W is equal to negative 150 kilojoules. Take note na yung sign ng ating work, it should be negative because of the fact that work is done on the object. In other words, work is done on the system. If the object's elevation increases by 30 meters, according to this statement over here, then we can just say that Z2 minus Z1 is equal to 30 meters. Also, according to our problem, its final velocity V2 is equal to 60 meters per second. Since the problem says that there are no other interactions between the object and its surroundings, we can just say that the heat transfer between the object and the surroundings is just equal to 0. So, walang heat na pumapasok sa ating system, walang heat na lumalabas because it's not interacting on the environment on the first place. Therefore, Q here is gonna be 0. Also, we can assume that there are no frictional forces because of the same reason that the object doesn't interact with its surroundings. Therefore, there are no changes in temperature. And since we know that the internal energies U1 and U2 are functions of temperature, in this case, functions of the same temperature since there's no change in temperature, we can argue that U2 minus U1 is just gonna be equal to 0. Therefore, rewriting our equation, we have negative W is equal to mass M multiplied by 1/2 times V2 squared minus V1 squared plus G times Z2 minus Z1. This is now our final governing equation. Take note that in order for this equation to give us the correct results, if we are in SI units, W should be in joules, M should be in kilograms, the velocities V2 and V1 must be in meters per second, and the elevations Z2 and Z1 must be in meters. So now let's substitute all the values that we know. For W, we have negative 150,000 because we know that negative 150 kilojoules is just negative 150,000 joules equals the mass, which is 140 kilograms, multiplied by 1/2 V2 squared, so that is just 60 squared, minus V1 squared, plus G, which is 9.81 meters per second squared. It should be in SI units, multiplied by the difference between Z2 and Z1. And according to our problem, it's just equal to 30 meters. The units are all good. The work is in joules, the mass is in kilograms, the velocities are in meters per second, and the elevations are in meters. Therefore, we are using this equation correctly. So, you can solve this manually, like you divide this by 140 and then subtract 9.81 times 30, and then multiply both sides by 2, subtract negative 60 squared, and multiply everything by negative 1, and then finally take the square root of whatever that expression is. But in my case, I'm just gonna use my calculator and let my calculator do the job. So what we're gonna do here is that let us just input the entire equation. So we have negative of negative 150,000, that's just 150,000 equals, so we press alpha and this button over here, and then input the remaining expression. So we have 140 multiplied by 1 over 2, so 1/2 60 squared minus V1 squared. So what we're gonna do here is we let V equal to X in our calculator. V in our expression over here is gonna be X in our calculator. So we have 60 squared minus X squared plus 9.81 multiplied by 30. Okay? So let's take a final glimpse in our equation that we encoded in our calculator, so we are sure that our answer will be correct. So this is one equation, one unknown. We can just let our calculator do the job for us, do the algebra. So in order to do so, we can just press Shift and then this button over here, the one with solve. So Shift solve, basically tinatawag nila itong Shift solve technique. And then we input a reasonable number as an initial value. Take note na ang ating mga calculator ay gumagamit ng numerical methods. And when we are using numerical methods, we need to input initial values. Okay? So let's guess an initial value, let's say 10, no? Should be positive because of the fact that in our diagram over here, you can see that it moved up. And according to the problem, its elevation increases by 30 meters. Therefore, the velocity should be upward, should be moving upward. So let's press enter and press enter one more time, or equals. Then we have the value for x, which is 45.23. Therefore, we can say that V1 is just equal to 45.23 meters per second. This is our final answer. Let's solve one more sample problem before we end this video. Measured data from pressure versus volume during the expansion of gases within the cylinder of an internal combustion engine are given in the table. Using data from the table, A, determine the value of n such that the data are fit by an equation of the form PV raised to n is equal to a constant. And letter B, evaluate analytically the work done by the gases in kilojoules. Use 5 significant digits in your calculation. So makikita ninyo sa ating table na meron tayong 6 data points and we have values of pressures which are in bar. Also values of volume which are in cubic centimeters. On the right, you can see that we have the diagram of the pressure versus the volume, or basically we have the PV curve. Ang pinaka-goal ng problem na ito ay i-define ang expression PV raised to n is equal to constant based on the values of pressure and volume that we have over here. So let's say we have PV raised to n is equal to some constant A. First, let us isolate P and V from each other. So we have P is equal to A over V raised to n, or P is equal to A V raised to negative n. So now, how are we going to perform curve fitting? So when you say curve fitting, it is the process by which you are solving the values of certain constants, in this case the value of A and negative n, more specifically n because n is the one that we're looking for in this problem. But in the process, we will also be able to solve for A. How do we do that? Pretty much all calculators can perform curve fitting. So to do so, let's just press menu and then go down to statistics. And as you can see here, there are different forms of equations where we can perform curve fitting from. And in this case, we are interested in the form P is equal to AV raised to negative n. And sabihin natin na ang P ay yung Y, yung V ay yung X, Y being the dependent variable and X being the independent variable. A is just itself and negative n is, let's say this is gonna be B. Okay? Going back to our calculator, it is not yet in the first selection, but if we navigate further, we can see here that item number 3 has the form Y is equal to X raised to B, where A and B are constants, Y is the dependent variable, and X is the independent variable. So we select form number 3. Now we input the values of X and values of Y. So take note that since V are the independent variables, then this should be the values of X and these should be the values of Y. Inputting them in our calculator, we have the values for the volume first. We have 300, 361, 459, 644, 903, and 1,608 cubic centimeters. Inputting the corresponding pressure values, we have 15 bar for 300 cubic centimeters. We have 12 bar for 361, followed by 9, 6, 4, and finally 2. Now we press AC because the values of the X and Y are going to be stored already. And then in order to solve for A and N, we can just press option and then select regression calculation or regression calc. That's number 3. You can see here on the screen the values of A and B. So let us just write down the values of A and B. A being 14,044 and B being negative 1.1996. Take note that B is just your negative n. Therefore, from here, we can say that n is equal to 1.1996. Now, if we write the pressure as a function of the volume, we have this. Therefore, we have P is equal to 14,044 V raised to B, which is negative 1.1996. So this is our pressure as a function of volume. Next, we answer letter B. Evaluate analytically the work done by the gases in kilojoules. Take note that work, by definition, is equal to the integral of pressure P as a function of V multiplied by the differential volume dV. And it should be evaluated from the initial volume V1 to the final volume. In this case, it's V6. Inputting the numbers, we have 300 as the lower limit of integration and 1608 as the upper limit of integration. Take note that they are both in cubic centimeters. P therefore is 14,044 V raised to negative 1.1996 dV. You can integrate it manually, but since it is a definite integral, we can just use our calculator to integrate this expression. So we press AC and then go back to our original mode. It's mode number 1. And input the definite integral. So let me just type these values. Press equals. We have 6,417.4. Let me just write that down. 6,417.4 bar cubic centimeters. So take note that our PV diagram, the pressure here has a unit of bar, and the volume here has a unit of cubic centimeters. Therefore, the integral, the area under the curve over here, should have a unit of bar cubic centimeters. Now, according to our problem, we want to evaluate the work analytically, work done by the gases in kilojoules. So, if you can recall, kilojoule is just equal to kilonewton meter. So, as you can see here, we have a unit of pressure and a unit of volume. So, what we will do here is to force this expression to show an SI unit for pressure and an SI unit for volume. So, in this case, we would expect kilopascal times cubic meters. Pipilitin nating makuha ang ganitong form in order to convert this. So, in order to do this, let's multiply both the numerator and the denominator by m squared. So, we have m squared over m squared. This then will give us kilonewton per meter square multiplied by cubic meters. And you know that kilonewton per square meter is just kilopascal. Now, let's proceed with the conversion. Take note that for every 1 bar, there are 100 kilopascals. And for every 1 meter, there are 100 centimeters. So, how do we deal with this? We put 1 bar at the bottom, 100 kilopascals at the top. Here, we have 100 centimeters at the bottom because we have centimeters here at the numerator, essentially, and then 1 meter at the top. So, since this is cubed, then this expression must also be cubed in order for cubic centimeters to cancel out and then also bar to cancel out. Inputting these values in our calculator, we have 6,417.4 times 100 divided by 100 cubed. This is equal to 0.64174 kilopascal times cubic meters, or in other words, kilojoules. This is our final answer. And as you can notice, the work is positive because of the fact that the work is done by the system. Thank you for watching this video. I hope you learned something and see you in the next videos.